Hello everyone. We have a question here. How many terms of this arithmetic progression 9, 17, 25, so on must be taken to give a sum of 636? So the question given to us is how many terms of this arithmetic progression when added 9 plus 17 plus 25, this is an AP, which when added till which term? How many terms? N terms gives you 636. So we know the sum of the terms, we know the first term which is A, and we know the common difference also. Let us write down whatever we know. A is equal to 9, A being the first term of the arithmetic progression. The difference D is equal to 17 minus 9, which is 8. And the sum of the n terms, we do not know how many terms, that is what we'll have to find out. We'll have to find out the number of terms n. So sum is given as 636. Now in our earlier video, we just saw that, in fact we derived that the sum of n terms of any arithmetic progression is given by this expression, n by 2 into 2a plus n minus 1 into d, where a is of course the first term of that progression and d is the common difference. Now let us substitute whatever we know in this particular expression and try to find out. We'll substitute in this equation or this formula and try to find out the number of terms which is required to be added up. So we have 636 is equal to n by 2 into 2 multiplied by, we know A is 9 plus n minus 1 into, we know D the common difference which is 8. So let's simplify. On simplification we get 636 is equal to n by 2 into 18 minus, let's distribute the 8 to both 8 n and minus 1. So 8n, this is an addition sign, 8n minus 8. Right? Now further we can multiply both sides of this equation by 2. Just to eliminate this 2 here, we'll just multiply both sides. So we would get 636 multiplied by 2 is equal to n into 18 minus 8 is 10 plus 8n. So we have simplified this. Now distributing the n, we get, let's have 636 into 2 as it is this side. We have 10n plus 8n square. Now we are getting a quadratic equation which we'll have to solve. But before solving, the first thing we notice is we can divide both sides of this equation by 2 without altering the values on both the sides, without in fact affecting the equation. So dividing by 2 we get 636 is equal to 10, not 10, it is not 10, it is 5n. We are dividing by 2. We can divide both terms of 10n by 2 and 8n squared by 2. We get this, which can be rewritten in the standard quadratic form as 4n squared plus 5n minus 636 is equal to 0. We are just subtracting 636 on both sides of the equation. Now solving for n. We'll have to find the factors of 636 and 4. Any two numbers, the factors of these two, we'll have to find two numbers in such a way that they should add up to the middle term plus 5. That is, we are aiming to split the middle term. So how do we split? First, find factors of 636. Let us do the rough work here. Finding the factors of 636. Actually, we need factors of 636 into 4, but let's find this first. Look at it, says that it's divisible by 3. 3 2s are 6, 3 1s are 3, 3 2s are 6. This being an even number, it's divisible by 2. 2 1s are 2, 0 and 2 6, 12. Now further, again it's an even number, so 2 5s 10 and 2 3s 36. Now can we divide 53 by 3? No, since it's not divisible by 3, it's not divisible by 6 and 9 also. And what about 11? No. 13? No, because 13 into 4 is 52. So 17, 17, no, 17 also is not divisible. 90. See, we'll have to look for numbers till 27, at least till half of 53, 26 or 27. After that, we don't have to see whether it is divisible or not, because of course those numbers would be larger than 53 divided by 2. So we don't have to check. But I think, or as far as we have checked, 53 is a prime number. I sincerely advise you to just take a pen and paper and try to work this out, see if there are any more factors. But 53 is a prime number now. Of course, we have done. I'm just asking you to do it for your own practice. So let me write the factors of 636. 636, in fact, we need the factors of 636 into 4, isn't it? 636 into 4. So it is equal to 53 multiplied by 2 squared into 3. We have taken these numbers now and multiplied by one more 2 squared because of this 4 here. So now our purpose is to find two numbers which multiply to 636 into 4 and which add up to 5. So have we found those two numbers? It seems like we have found those two numbers because it's, of course, it's these numbers, one of the numbers should be as large as 53 because the other number would be plus or minus 5 of 53, isn't it? Because it adds up to 53. So let's find what is the result of this product. 4 into 3 into 4, which is 16 into 3, which is 16 into 3, you get 48. And 53 minus 5 is exactly 48. So we have found those two numbers, those two factors of 636 into 4, which would add up to 5. So let us rewrite this equation now. By splitting the middle term. Since we have found those two numbers which can be used to split the middle term. So rewriting it, we get 4n squared. It has to be a positive 53n because we have a plus 5n here, minus 48n minus 636 is equal to 0. One is plus and the other is minus because it adds up to 5 and it multiplies to minus of 636 into 4. Now for taking out the factorizing the common terms, we have n into, because only n is common in the first two terms, only n is common to both the terms, so 4n plus 53. And what about the third and the fourth term? What could be common? Let us try to factor what could be common. Now, within the brackets, it's going to be the same 4n plus 53. So it is a negative sign minus 4 into 12 is 48. So 12. And that's it. So and 12 into 53, you can just check it for your own benefit. 53 into 12, of course, gives you a minus 636. Yeah, and then the negative sign also is there. Now, this is equal to 0. Now, the two factors of the quadratic equation are, one is 4n plus 53 and the other factor is n minus 12. Out of these two factors, the first one, that is 4n plus 53, would not hold good for us. N is equal to this value of n being negative and a fraction will not hold good for us because we are aiming to find the number of terms in the arithmetic progression, which can't be negative, which has to be a positive integer. So the first factor is ruled out for us. We'll have to consider the second one. N minus 12 is equal to 0, or the number of terms in the arithmetic progression should be 12. There should be 12 terms, so that the 9 plus 17 plus 25 plus so on till 812, 12 terms. It should be 812. Whatever the term is, it can be easily found out, is equal to 636. So our answer here is n is equal to 12. I hope you understand. Thank you.